Yeah.
Very good. I think we're going live, and we are live. Hello, everyone, for our second live stream of the day. Very, very good to be here. This is live stream, I believe we're at number 75, which is quite exciting. It's been a long, very long way to the top if you want to rock and roll, as AC/DC would say. But like I said, today, I want to just touch on really quickly what we're about as a community, a couple of announcements, a couple of reminders. The Data on Kubernetes community is committed to helping folks make the journey to start working with data, working with stateful workloads, databases, etc., on Kubernetes. Today's speaker that we have is someone who's been doing this for a while. I'll also put in a link to a great podcast that he did about 2 years ago. And I want to know a little bit more about his journey, about how he got involved in this, because I think that'll sort of open us up to perhaps some resources we should keep in mind, some cultural things regarding what kind of mindset and mentality you need to have if you're going to be working with data on Kubernetes. So very, very excited to have Tamal Saha with us today. He is very experienced in this area. So we're definitely going to be getting questions as usual. You got to know that you can put your questions in the chat here on YouTube. Another thing, just as a quick reminder, we are celebrating our second co-located event in KubeCon, which will be on October 12th, and hopefully we'll have Tamal as a speaker. But if you are interested in giving a talk about your experience working with data on Kubernetes, working with stateful workloads, and particularly from an end user perspective, get a customer involved, I'll leave the CFP here in the chat, so you can definitely check that out. And if you have any questions, of course, you're always welcome to jump in on Slack. Anyway, Tamal, very, very nice to have you with us today. Can you just tell us a little bit about your background and where the idea of working with data on Kubernetes in your particular case, where'd that come from? How'd that happen?
Yeah, thank you, Bart. Thanks for inviting me and Fahim from my team to kind of talk to your audience today. So my background, I've been, working with Kubernetes since 2015. So actually around the time I was working at Google as a software engineer. I was part of the Google Cloud, which is now called like a Firebase part of the team. So that's like their mobile cloud startup that they acquired. And, we're kind of doing internal development work, and it became, Kubernetes came out. And then we could see that the interest in containers was really growing, and felt like Kubernetes was the missing piece, because at Google we were using things like Borg. You may have heard about it. It's like the Google sort of internal Kubernetes like system that is used to deploy all of their production applications. And I figured that this will be a great time to kind of actually go and do my own thing. So kind of I left Google and started working on what's now called AppsCode. And in the beginning, we're trying to kind of build like a SaaS type of application. And I started doing that. We kind of found out that we wanted to do dog food, right? Like we wanted to run everything on Kubernetes, because we were we're like telling people like, hey, you should run Kubernetes, so we should run ourselves too. And one of the things that we struggled with is like managing the data side of things, right? Like how you run databases, because back in the day, I'm talking about like the stateful set even didn't exist. Like we were using deployment to run databases, and that usually don't go very well, because you can, you can run only one pod, because you cannot really mount more than one volume in a deployment, right? Like so, and if anytime pods restart, you have like a minor outage. So we struggled with running our service on Kubernetes as a whole, because the database thing wasn't really working. And then kind of I became familiar with this idea of this operator controller, and we figured, okay, hey, that seems like a problem that people would like to solve, because we are struggling with this, and let's see if we can solve it for ourselves at least. And so kind of we built an operator supporting like a Postgres and Elasticsearch as the primary database, because that's what we were using at the time as like and then we kind of open source it to see if anybody else would care about it. And so I'm talking about like early 2017, we kind of open source it, and on GitHub, and it started to see a lot of activity from people, because but I would say not a lot of production activity at the time, but people were just curious, like if I can run databases on that. And there, at the time we were still calling it like a third-party resources, TPR, and there was no like a CRD, which is called today. so kind of it kind of grew from there. Really, people wanted to use it. We found and then started requesting for additional databases. We added support for it, and over time, this idea that okay, yeah, you can run really like a production quality database with all the functionality that you would expect, and frankly, and really simplify the operational side of things, right? Like databases can be very tricky, right? Like every time you are running a cluster database, like there's the failover scenario. A lot of things has to happen correctly for things to recover, and if you can automate all of that, and over time we find out that yeah, you can do all of that. It's a lot of work, learning to knowing Kubernetes very well, and also learning about the database very well, so that you are able to handle all those failure scenarios properly. But if you put in your time, over time you can get to a system which is fairly stable. And frankly, Kubernetes itself evolved over time. So like all the stateful set, and then like this, the storage layer got a full redone, right? Like the CSI stuff. Then the CRD thing became like really, in the beginning, CRDs or the TPRs were not that, like you're not able to do a lot of things. Like, like all this validation webhooks and stuff was very important, right? Like if they, there are times where user will, do a kubectl apply and they have like a small bad YAML, and that will break the operator because the operator cannot detailize the YAML input that is coming from the user. And so those things got fixed, right? And it became really possible to run a stable, when I say production grade, what I mean is something that is stable, like, users cannot just break it, right? Like what you would expect. And then something that you can upgrade, right? Like over time, became possible with the Kubernetes. So I would say, yeah, so that's kind of, how my journey started. And over time, we kind of really focused on KubeDB because it seemed like a area, that I thought that were quite important, but nobody was really solving it, because the people had this opinion that you're just going to run cloud provider services. Why even bother with Kubernetes and database? But I would say if you look at, how the trend is going in the last few years, I mean, a lot of major database vendors themselves are offering their Kubernetes operators, and then like even there are like a lot of interest in the user community. So
yeah. I think these are all great points and very solid summary. And this is one of the things that you mentioned as well in this the data engineering podcast from a couple of years ago, is that you see more and more people are trying to figure out, okay, I'm gonna need to get into this space. How can I do it? What's the best way that's going to work for me? Operators seem to be one way to do it. Obviously, there are other ways, and we'll probably get to some of those, I imagine, in your presentation. But I think one of the really big questions for us is there's the what is data on Kubernetes and how is it done? Then the other question is why. And something that you mentioned a couple of years ago, and I imagine you'll be touching on later, is, well, there are different reasons, but a very strong one is wanting to have everything all in the same place. It's like, okay, we should be able to do everything in this environment, so we don't have to be, separating different things in different areas, having separate stacks. That can bring on certain complications, different kinds of costs. We were talking about that. It could be just a financial cost, a cost in time, resources, what kind of teams you might need to have. So when approaching this question, why data on Kubernetes? What are some of the things that you generally, bring to the table for that conversation?
I would say that those original, reasoning is still kind of really the valid ones, right? Like I think the first one is just the operational simplicity, right? Using one stack for all parts of your application, right? Like you're running your microservices on Kubernetes, and then you're running maybe your monitoring stack with Prometheus also in Kubernetes, and then you want to run your database also on Kubernetes, and not just database, but like other stateful applications, like if you're using like a Kafka or Nets or things like that, that also has like a local data. All of that potentially you want to run on Kubernetes because it just I know that when people hear about like operational simplicity and Kubernetes, they might think, okay, what I'm talking about. But once you are already on Kubernetes, it does simplify, like not having to think about 5 different systems, right? Like you just, okay, everything is on Kubernetes. I know how it works. And you can set up your monitoring. If something goes wrong, you are able to connect one thing to other. The other big thing has been that the portability. I know that I mean, when Kubernetes started, one of the big thing was portability, and it is it's still a kind of a, you still have to make good choices to achieve portability with Kubernetes, but it is doable. And for a large part of your application, like, if you are Kubernetes native, meaning like running everything on Kubernetes, you can go from one cloud to another. And it is not like, okay, I'm not going to do that for a multi-cluster. It's not necessarily that, but I mean, sometimes you have two teams. One team may be running on one cloud for one reason, another team may be running on one other cloud for a different reason, but the ops team or the platform team who's kind of managing all of that cloud stuff behind the scene, they have a way to kind of, okay, give you a common infrastructure that, just they can manage across all cloud, right? Like, so those, and then obviously there's this thing, which is actually quite a bit of a, I would say, business-wise important part, right? Like, there are a lot of organizations who are not able to use cloud, usually government organizations, financial, medical, health, all of that, and they are modernizing their digital journey with Kubernetes, like, and in those scenarios where they are running on their own data center, uh, they are not really able to use cloud services, so they need to use something like a Kubernetes, and they are really looking to use something like a KubeDB type system where they can manage like all the databases internally. And the last one is obviously cost. So it's cost kind of, obviously there's like a different types of cost, right? So there's the cost of the engineering resources, basically the engineers that you have to hire to manage all of that. But once you have hired somebody to do your microservices stack, it's no more cost to actually also run databases for them, manage databases for them. The other thing is, these managed services, actually, if you look at how much they cost quite a bit. I mean, I'm talking about just on an infrastructure cost level, you can actually save quite a bit. Like, if you look at any of these managed services out there on the cloud, right? Like, if you look at, okay, what is the cost of the VMs, and then like what they are actually charging for as a managed service, on a small instances, it's not much. But then the moment you have like a large databases, which pretty common we see in production, like the cost could be quite a bit. So when you're running on Kubernetes, you kind of slicing that two part, right? Like, you're still going to pay your underlying cloud provider or infrastructure provider for the infrastructure cost, but the rent extraction that is happening at the software services level, that you can escape from some of that by using a Kubernetes native tool like KubeDB. So I think that's those, I would say, come the reasons
Great.
why.
Yeah, very, very solid. That being said, if you want to jump into your presentation, go right ahead.
I'll share my screen.
Okay. Just really quickly as well, too, I'll put the link in for KubeDB if anybody wants to check that out while we're talking.
Are you able to see my screen now?
Yep, perfect.
Okay. So yeah, so this is kind of will be continuation of what we just talked about. So I mean, you already know it's Kubernetes, is how people are really running sort of modern containerized applications, and on cloud or on-prem. But despite that Kubernetes has become so popular, especially it has such a nice support for running microservices or stateless applications, the data layer still has quite a bit of challenge because Kubernetes doesn't really provide you. It provides you sort of the underlying primitives, but doesn't really kind of provide you the knowledge that is required to run data application or stateful applications on Kubernetes. And today, if you are running your applications on Kubernetes and you need a database, you kind of have, I would say, three sort of solutions, right, or options. One is go with whatever the cloud provider is offering, right? AWS, RDS, Azure, Google Cloud, they all have their some form of managed database service. Obviously, you can go with a hosted database service that is usually provided by the database vendors themselves. I mean, this has become like, pretty common these days, like Mongo Atlas or Elastic Cloud, Redis Cloud, all of that. obviously, and the third option is that, okay, no, you run the Kubernetes cluster and run your databases inside Kubernetes, right? And kind of just use one stack. Now, the question is, the question that we were just talking about, like, should you even run databases on Kubernetes, right? I mean, there's the why. Also, is like, is it? I mean, is it even reasonable, right? And I would say that it has become very reasonable of late, right? In the last, I would say, couple of years. I mean, we started almost 5 years ago, but like in the last 2-3 years, I would say it's become quite practical to do it just from engineering point of view. Like, Kubernetes is now really battle tested and very widely adopted, right? Like, you can go to any cloud, if you have a bunch of VMs, you are able to deploy Kubernetes. It's not that difficult anymore. The idea of this stateful set that's built into Kubernetes today, like, which is kind of giving you pods with the stable DNS names, that is great for this running stateful apps, because this databases usually expect to be able to use some kind of a machine so that they have a stable name, because they usually communicate with each other or sync data using these names. And then the concept of this custom resource is GA since, I think, September 2019 or 2020, I think 2019, and it has like the first class support any other Kubernetes native resources, that built-in resources, right? So when you are building this kind of database solutions, you are able to give users all the functionality that they expect, right? Like, obviously the kubectl support, like RBAC support, like having proper validation so that users cannot, like, make a simple mistakes and mess up the database and all of that. Those are possible today. The Kubernetes storage layer kind of got a complete redone, right? Like the CSI driver now, which is kind of going GA of very recently, right, in the 1.22, I believe. So this CSI drivers is enabling things like volume expansion, volume snapshot. So effectively, these things are, I would say, after people have managed to run a database on Kubernetes, the first thing that they care about is like, how do I back it up, right? Like, how I back up a database, restore it. So those things are much better supported with CSI drivers today. And then security in terms of like certificate management, right? Like, how we make sure that my database has the TLS set up. Those things are now much easier with something like Cert Manager, right? It's become sort of pretty much the standard way people are managing certificates in Kubernetes. And then operators, right? Like, so that these Kubernetes, operators which can kind of, this, I would say, really the missing piece in running databases on Kubernetes, because databases usually have some database specific approach or sort of procedures that you need to follow when you are managing them, right? Like, meaning when you provision them, how you set up clustering, when there is a failure scenario, how you recover them. Those things needs to be captured in some kind of automated fashion, because in Kubernetes you cannot really have a manual step, right? Once you ask Kubernetes to manage a system, from that point on, if things things really has to be automated. I mean, I would say this has been really one of the bigger challenges for people to adopt Kubernetes, because in the old days, you'll probably deploy stuff with Chef or Puppet or things like that. That will be a one-time deployment. But then, like, if something goes, maybe you periodically go and update the database and whatnot, but there's not going to be a runtime thing, right? Like, there's not an automated failover or things like that. If there's a failover, you get an alert, then you have to do something, fix it. But with Kubernetes, that's not a realistic approach, right? Like, because if there is a failover, Kubernetes is going to restart the pod. And if the pod doesn't restart in the correct way, then you might lose data on that pod, because that data might get corrupted, because it's now has become like, a lot of common scenario is like a cluster database that it becomes into a split brain scenario because that pod now doesn't know that it was part of a cluster. So it became like its own cluster, and now you have a problem. So what I'm saying that there's things needs to be kind of properly managed when you're trying to run database in Kubernetes because of this automation. This automation is actually a very good thing, because when there is a failure, your recovery is much faster. There is not a manual step, but getting this manual step automated. That has been one of the jobs or task of this operator, and that has been a long journey, I would say, to get there. And then obviously I talk about backups and recovery. Today there's like a lot of tools for doing those. And as you can see, like database vendors themselves, like look at Mongo, Elastic, all of the, I mean, Couchbase, they all have their own sort of Kubernetes operators today. So I mean, database vendors are themselves seeing the benefit, or I would assume ask from their users, right? Like, because actually they are also looking at their users and doing what their users are asking from them. So it has become quite popular to actually, or I would say, from a technical point of view, it has become possible to and run a production ready database on Kubernetes today. So, like I said, you're not alone, right? Like, I mean, if you look at all these big names on this slide, like DataStax, MongoDB, Elastic, CorpusDB, Percona, like Redis, I mean, they all have their Kubernetes operator or some form of Kubernetes native solution that they can run. I mean, today it is it will be very uncommon that to see projects that doesn't have a Kubernetes operator. I mean, so it's there. Now, getting back to that question, like, what are the factors you should consider when you are trying to run a database on Kubernetes? So this is kind of some of the things that we see, sort of some of the deciding factors. Like, based on your answer to these questions, you might go, you might have one or more solution available to you, right? So we'll go with them. Like, let's say you're going with a cloud provider solution. So if you go with the cloud provider solution, I think the primary benefit is that, like, really ease of use, right? Cloud providers usually offer like a bunch of different databases, and they manage all of it for you, right? And then usually they have pretty easy, like one-click type of deployment setup, right? Like, they deploy it, maybe you get all the observability, like a dashboard and all of that. They give you a way to kind of back up, restore these databases. So it simplifies a lot of the operational aspect of the provisioning a database. It is important to understand, though, that cloud providers aren't really your DBA. They are not going to, if you have a slow query, they are not going to tell you how to fix that, right? You still have to do it manually or yourself or in-house. But what they do is they make it very easy to kind of provision and sort of manage the day-to-day life cycle of a database, right? Like backing up, have a TLS setup and all of that. I think the issue with this is usually, if you have a some kind of regulatory requirements, like, okay, I need to keep my data in this location, or maybe not on cloud, things like that, then this is not an option for you, right? Your cloud itself is not really an option for you at that point. If you want to run things like an air-gapped cluster, it's not. Then other thing is, the latency aspect does come into play, because you're running your application in one data inside one VPC maybe, but the database services that are provided usually running on a different VPC. So you kind of have to go through this cause VPC extra latency. I mean, if you're running in Kubernetes, it's just in the same VPC. So things are, just within the same cluster. And this can be even more important. Like if you are trying to use a service, you want to run, depending on which cloud you are on, you may not have the same quality of database service, right? So, and sometimes depending on which region you are on, some database vendors doesn't have the same service in all locations, right? So it could be a problem for you. You could be limited in terms of your choice. Obviously, vendor lock-in is an issue. I mean, people might say, okay, hey, maybe I'm using Postgres. How am I vendor locked in? But you still have to kind of go through the database vendors approach of deploying or provisioning the database. Maybe you have written up some Terraform script, or maybe, I don't know, maybe you're still using Chef and Puppet, or manually do this stuff. And so you kind of, or maybe Pulumi, or all of those things. But so now we kind of have this provisioning scripts that are kind of, tied to the database, the cloud provider itself, even though your database itself is, maybe something like a Postgres, which is not locked into a specific anything. And then I would say, if you have things like IoT Edge, so it's just kind of really a version of running on-prem, right? Like a lot of people have use cases where they are running like, telcos, I would say, like they are running like their full kind of the 5G stack on sort of their endpoint data centers. And they cannot really just use cloud in those cases, and so then they are stuck to, so they are using Kubernetes, and they need a way to run databases. And then price usually becomes another factor, right? So price, it's a kind of a complex topic, obviously, but the database services could be quite pricey. I mean, if you look at the price of the actual underlying the VMs or the machines that they use, and compare the price of a managed service, even a lot of times it's quite interesting because they are just running open source software on the VMs, but then they are adding quite a bit of markup to that VM price. And so if you're running on inside Kubernetes, you could potentially save on that. And other big thing we have seen is the sort of third-party integration. So for example, like one of the things we know, or we have been told by our users, is that they are using something called DBGM. It's a Kafka, like a change detection system. And they are not able to use something like a AWS RDS because it doesn't allow you to kind of install like a custom plugins. It may have changed in the meantime, but it used to be true at least, even 6 months ago. So there are things like that where, yes, the benefit is the ease of use, the operational simplicity that it brings. But then like there are other vectors where you kind of lose if you are going with a cloud provider, or it's not necessarily cloud provider, but it's just any managed solution will put a kind of have their set of features that they offer, right? So the other things, if you need anything else, you're limited. So same issue goes with the database vendor provided kind of like a cloud database solution, right? Like database as a service. I mean, here you have the additional issue that obviously the database vendors only offer one database, whatever database they're building. And if you are on a cloud, right? If you are on one of the three major clouds, AWS, Azure, or Google Cloud, usually you have a choice. But then, like if you are using any of these other clouds, right? Maybe you are using something like DigitalOcean or Linode. I mean, you are not able to really use those database vendor solutions because they don't really support those. Kind of, I would say, kind of this sort of. There's the hyperscalers, and then the guys, everybody below that, right? Like there's non-hyperscaler clouds, usually not supported by these database vendors. So you're kind of limited in their option. Now let's look at what is, what it looks like if you're trying to run in Kubernetes database. So if you're trying to run this in Kubernetes, I mean, obviously, there is no limitation in terms of your choice of database, right? If you are able to, if the database vendor has a Docker container, you are able to run the database. I mean, it's it's pretty straightforward to just get up and running. You have no limitation in terms of where you run your workloads, right? You can run on cloud, you can run on-prem, you can go with IoT. Like if you have a lot of edge clusters, you can use it, right? If you have air-gapped requirement, like, it has to be completely separated from outside world, you can do those, right? You just load all your Docker images inside a private registry, deploy your cluster, deploy your operator, you can run it. I already mentioned about this latency thing, right? So you don't have this, because everything runs inside the same sort of pod network. So there is not really a major latency penalty that you have to pay because it's not, the packets are not like, going through layers of indirection every time. And then the performance, right? So the performance comes to like especially for on-prem, like a lot of people are running sort of databases, and they have like a really fast local disk, like basically like NVMe disks, and you can take advantage of that with Kubernetes, right? Like you kind of have like a really fast, like if you have a requirement for a very high, write speed, IOPS requirements, you are able to do that with the, obviously you have to pay for those additional hardware, but you are able to do it. So yeah, the security, I mean, you have kind of full control, right? I mean, security as everything else, right? Like you have to set it up properly, but once you do, you will get more security out of a Kubernetes-based solution because you have more control over what things are there compared to a database, managed solution, because there you are limited to what you are offered. Observability, yes, with the Prometheus, Grafana becoming sort of the standard observability stack for Kubernetes, it's pretty easy to get a good observability solution set up for your database. Obviously, because you are running Docker containers, there is no limitation in terms of what third-party tools you can have, right? Like you want PostGIS with Postgres, great, just run a Docker container with the PostGIS plugins built in. You want timescale DB with Postgres, you can run it, right? You want to use things like this DBGM or stuff like that. That's any kind of basically database plugins or extensions that exist. You can just use it because you are running a Docker container. I would say the challenges, and even in terms of pricing, right? Because you are not paying for this, this high cost of managed service. It could be quite, cost saving in terms of just a pure dollar value savings. Now, the challenge usually is the ease of use, right? Because it's it comes to the maturity of the solutions or the options that you have available for running database on Kubernetes. So I would say that from the Kubernetes point of view, things are much more stable or mature now. Yeah, obviously there could be things that could get better, but then usually if you're using something like an operator, you also need to kind of focus on that. And those operators, takes time to get stable and mature. But I think, over time you'll see that there is no limitation in terms of what you can do. Disaster recovery, I mean, same as like how you do backups and recovery. I would say that those things are also kind of getting easier today, like, with the Kubernetes, CSI and everything. I think the only thing that will be left is like operational complexity and then learning curve. Operational complexity, usually, what I'm trying to talk about is, yes, all of these operator and stuff is possible, but you kind of today still have to a lot of times go to a website, download stuff, deploy stuff. You kind of, if there's a bug, because a lot of things are open source, you may not have proper support. So, okay, something is a problem, you kind of have to figure it out yourself, maybe go to a Slack. I mean, it's still kind of quite a bit of work to get something, up and running, right? It's not like where you get on a cloud provider, okay, you are maybe paying more, but, it saves you time because you just go click, it works, and that's it. But, this, I would say this is not a fundamental limitation of running database on Kubernetes. This is more like a state of the world today. And frankly, within a lot of, like companies like us and other people who are working in this space, really addressing this issue. So it is, I believe in a few more years, it will get much more, easier. So now let's say I have convinced you by this time that maybe it is possible or reasonable to run databases on Kubernetes. I think one of the big questions people usually get is like, okay, do I just use like a Helm chart that I got, or do I need like an operators? And the question here really is, looking at what Helm offers and what operators offer, right? So Helm, the benefit is that, okay, you just do Helm install, the thing gets running. But if you look at Helm, at its core, it is really like a package manager. It is not meant to be a system that manages your day-to life cycle of a database, right? Like the things that I'm talking about, like, okay, how you do clustering, and then like how you do failover, how do backups. So Helm is good for deploying stuff, but then what gets deployed isn't really in Helm's parlance, right? Like you have to kind of have your own application or kind of a Kubernetes operator that knows about that particular database and manages that aspect of it. So yeah, so if you are really running like if you're just doing a demo, you can use Helm to just deploy a database and do its thing, right? Because you don't care about what happens the next day. But if you're thinking about like a day two, and think about how do I upgrade, how do I set up TLS, how do I scale up, scale down, things like that. backups, recovery, all of those sort of aspects that people would care about in a day-to settings, then you do need to go with an operator that addresses those concerns, or maybe a collection of operators that addresses those concerns. So when you're picking an operator, there is obviously choice, right? So we built an operator called KubeDB, but then there are like other ones. I would say, what has been our approach is that one operator that addresses or that manages all of your databases, sort of kind of a, I would say like a horizontal approach, you can say, like, support, instead of having like a separate operator for each database, and then each operator kind of working slightly differently. You have like one operator and that sort of manages all the databases. So that's kind of our approach with KubeDB. So it simplifies your management approach. And frankly, if you go today, like, a lot of people have written operators, but it's not get maintained after a while, because writing operators is quite a bit of a tricky stuff, primarily because it needs some specialized knowledge, right? Like you have to be pretty good with Kubernetes operators, and then also be kind of an expert in the particular database for which you are writing the operator, to actually get to a point where things are stable, mature, production ready, and that takes a long time. It's not like at least in my opinion, it's not a side project that you can do. It really isn't. You have to keep up with all of this, and and as a result, you have to pick a operator that is well maintained, at least. So that's where KubeDB comes in, and we try to kind of manage all your databases. And when I talk about, like, same thing works similarly. Like you want to set up a backup, so from the end user's point of view, the backup for every database looks pretty much the same. You give it a database reference, you give it a bucket reference where you want to store the bucket, so the backup data, and it kind of whatever happens behind the scene, all managed by KubeDB. It has to do various different things based on different database. But from a user's point of view, it's no different, right? And not just that, like you want to scale up, scale down to all those kind of a ops request, we call it, like a kind of a day two operations. Those are also similar across all your databases. So it kind of really simplifies that learning curve and the operational complexity, because once you know have used one database, you can use the other database fairly easily. And really, so KubeDB, one of our common use cases that we see is used as a internal DBAS as a service, like database as a service, for people who are adopting Kubernetes. Yeah, so I mean, you kind of already talked about this, so like if you're going KubeDB kind of versus the operator versus the Helm chart approach, like, you get all these day-to aspects addressed for you, right? Like backups, updates, scaling up, CPU memory, storage, replica counts, or horizontal or vertical scaling, certificate management. And then, like, we also have a nice integration with HashiCorp Vault. So you want to like manage those credentials, like rotate those credentials. Those things are possible with the KubeDB managed solution. And then, because this is all custom resource based, so you get RBAC, right? Like you can restrict who can create a database in which namespace, which is effectively RBAC. These things are possible with the Helm chart. You just Helm install, so you usually don't have a control over that. And then, because this is all CRD based, you can use kubectl, or you can also use programmatically, right? So Kubernetes API server is a CRUD API, so you can go from any application, right? You can use Go or any Python, Java, whatever, to actually programmatically provision these databases inside your cluster. With the Helm, it's more like, okay, you have to shell exec and do stuff like that. So simplifies that aspect of it. So what databases are supported with the KubeDB today? So we try to, like I said, our approach is to kind of take a horizontal approach, right? If we want to make sure that any database that you need or use is supported. So today we support Mongo, Elastic, Postgres, MySQL, MariaDB, Barcona, ExtraDB, Redis, Memcache. We also have a support for ProxySQL and PG Bouncer, and frankly, we are looking to add support for more. In a way, we want to make sure that if you are running database on Kubernetes, KubeDB kind of addresses that problem or that aspect of your operational aspect of you completely. It's not, you don't have to go to 5 different vendors. So today this is where we are. So with that, this is what it looks like if you were trying to use KubeDB. So we actually use Helm chart to deploy the operator. So it's kind of a one command. So here you kind of basically Helm install, deploy the chart. So we had like a few different, so it's an open core product. So we have a community edition that can kind of use as a day one or sort of CI/CD type of environment. But then the day two aspect of the product is a enterprise product. So it's a, you have to basically buy a license to use it. But it comes with a 30-day free trial. So during that period, you can try it. But then you can work with us too if you have any, questions about the product. So with that, I'll hand it over to Fahim from my team. He's going to give you a demo of using KubeDB to kind of provision and manage various aspects of a MongoDB database.
Let's do it.
Thank you.
Thank you.
Stop my screen share.
Okay.
Thank you, Tamal and Bart. Let me
My
share
pleasure.
my screen.
Good.
Can you see my screen?
Yep.
Yeah.
Hello everyone, I'm Fahim, Senior Software Engineer at AppsCode. Today I'm going to show how to provision MongoDB using KubeDB. So before starting to the demo, let me show you my environment first. So I'm using kind version 0.10.0 and Kubernetes version 1.20.2. I have this Helm charts installed. The sub-manager chart is for the certificate management of the database, and the KubeDB chart is for the MongoDB database management, and the Prometheus chart is for the monitoring of the database, and the stash chart is for the backup and restore of the database. Okay, now let's jump into the demo. So this is the YML of the MongoDB. Here we are providing in the spec section, we are providing the version of the database. So this is a KubeDB specific version, 4.1.3 v1. This is the YML of the MongoDB version of the KubeDB. So as you can see, it has the meta information that KubeDB needs to manage this version, like the actual version number is here, the database image, init container image, etc. information are provided in this MongoDB version. We are going to deploy a replica set of 3 replicas. So we are providing the replica set information here. This is the replica set name, and it will have 3 replicas. We are going to have the SSL enabled on this database. So we are providing the SSL information here. As you can see, the SSL mode is required SSL, and in the TLS section.
What? Sorry, Fahim. Could you zoom in a little bit or make the font size bigger? Would that be possible?
I guess in the terminal, I suppose. Yeah.
I'm in the presentation actually.
Yeah, and if you when you go to the terminal, I think that's fine.
Okay.
Yeah, no worries. It just sometimes when going to YouTube, the quality decreases a little bit. So just so that it's a little bit sharper. That's all.
Okay. So here in the TLS section, we are providing the issuer ref. So what is the issuer? It is the cert manager issuer that issues certificates for our database. So we are providing in the issuer spec the CA of the CA here, in the secret name Mongo CA. So what the issuer does is uses this CA to provision our certificates. So in the config secret, we are providing a secret name config. This config secret holds the configuration of the database. Like we are providing a simple configuration here. The max incoming connection is 100,000. So in the monitor section, we are providing the Prometheus agent so that our database have monitoring enabled. And the port template section, you can see we are providing the request and limits of the database as 1 core CPU and 1 GB memory. Also, we are providing a 1 GB storage here. Let's apply the MongoDB database. Okay.
Yeah, it's good.
So the database is applied. As you can see here, the database is now in provisioning state. Also, the ports are coming up here. The first port is coming up here. While this is being provisioned, let me show you the version that KubeDB supports. So these are the version that KubeDB currently supports. The latest version that KubeDB supports is 4.4.6, but we are working to add the support for MongoDB 5, which should be out here on in a couple of weeks. Okay, as you can see, the first port is ready and in running state. Here you can see that two services. The first service is the primary service of the database, which points to the primary member of the replica set. And the second service is a governing service that points to all the ports of the database. As you can see that the primary service is pointing to the IP 132, which is the first port IP. So our first port is the primary port. Also, you can check the port is primary or standby from the levels. So if we check the levels of the first port, you can see that there is a level kubedb.com/role, which points to primary. So the first port is actually primary. So the second port is also up. We can check the second port's levels. As you can see, the kubedb.com role is standby. So it's the secondary port. Our third node is now coming up, which is now running state. Let me see the role of that node. As you can see, it's also a standby node. So as you can see here, the database is now in ready state. So let's exec into the database and see if our information matches inside the database. So as you can see, I'm execing into the database. So I'm providing the Mongo command here. Here I'm providing the SSL CA certificate and the client certificate as our database runs with TLS. And these certificates are mounted into the port, so you can use them directly from the port. So let's connect to the database. So as you can see, we are connected to the primary of the database. Let's check the version. So as you can see, the version is 4.1.3, which matches the version of our KubeDB MongoDB. Now let's check the configuration that we have provided before. It reflects here or not. As you can see, the max incoming connection is 100,000, which we have provided in the config secret. Okay, now let's insert some documents in a collection. Let's create a database named KubeDB. Then insert some data in a test collection. So we have inserted one document, two documents. We have inserted three documents. Let's see if they are in the collection. As you can see, the test collection contains these three documents. We will verify later after performing some operations that if the data is still here or not. Okay. So as we have enabled monitoring for this database. Let's see if we can see the Grafana dashboard. I'm porting the Grafana port. I've already installed the Prometheus Grafana. Let's check from the browser. We are seeing the Grafana dashboard. So I have already a chart created. So as you can see, here are some graphs. You can use your own graphs and import it here. You can have your own chart. Okay, let's now get to the next section. So now I'll show some DB operations using MongoDB ops request. You can ask, what is MongoDB ops request? MongoDB ops request is a CRD of KubeDB, which manages the day two operation of the database. Day two operations are such like upgrading the database into a new version, or the scaling vertically or horizontally, or like reconfiguring the database, reconfiguring TLS, etc. So first, let's see a upgrade operation. So this is a MongoDB ops request YAML. Here we are providing the type as upgrade. In the database reference section, we are providing our database name. And in the upgrade section, we are providing the target version as 4.2.3, which we want to upgrade. Okay, let's apply this YAML. We have applied the upgrade YAML. You can see that here, the upgrade ops request is now in progressing state. So what will happen now, the KubeDB operator will upgrade all the ports and perform necessary operation. It needs to be done to upgrade the database. So as you can see, the second port, which is it will actually smartly restart all the database port to a new version. So by smartly, I mean it knows which port to restart first. So this is the secondary port. So it will restart all the secondary port first with the new version, and then finally it will upgrade the primary port. So currently it's restarting the secondary port, the second port. As you can see, the database is now in critical state. So the critical state means that at least one of the ports are not ready. As you can see, this port is not ready, so our database is showing critical state. When this port becomes ready, you can see that the database will immediately become ready. As you can see, it is ready, and our database also became ready. Now our KubeDB operator is restarting the secondary port, which is this one. So it's now in terminating state. So our database is also showing critical, so one of the port is not ready. So this port is ready, and our database is also ready now. So now the KubeDB will update this primary port. As you can see, the IP here already changed to a new IP. As you can see, the IP is 137, which is the second port. So our new primary is the second port. As it upgrades the first port, which was the previous primary, before it upgrading that port, it actually changed the primary to a new one. Like it changes it to the second port, and now the primary is also upgraded. As you can see, our ops request is now successful. Also, you can see here in the database
Hello, Fahim.
Fahim, I think we lost your audio. That's okay. Also, we have a question right here. Tamal, I'm not sure maybe if you want to answer this. Someone asked, is the database usable in a critical state?
Yes. So what critical means is that one of the pods is like restarting, or usually like a terminating phase, but the database is still usable. The primary service is usable. We just indicate that we kind of wanted to show that to the user that it's from when it is ready. It means like all the pods are running, and you are able to connect to the database, and no issue there. But here in one of the pods are restarting, it kind of shows you that it's something is not at the 100% state. So it kind of we use the word term critical to show that. Yeah, but the database still is usable.
Okay, great. Thank you very much.
Fahim, are you able to hear us?
Yeah, it says that his microphone's on, but anyway, all kinds of things can happen when it comes to microphones. The demo's going very well, but the demo effect is now affecting the microphone. Maybe Fahim, maybe you wanna. I can mute him and then ask him to unmute. Oh, now he dropped. Maybe he's just gonna hop out and then hop right back in to see if that works. That's totally fine. These things happen. It's 2021 and we have to know how to improvise. So that's no big deal. That's all good. But up to here, so far, so good. My one question, I mean, obviously to have KubeDB to work for every single database out there, you know, maybe would be complicated, but are there plans to add more databases as well?
Yes. So we have plans to add support for additional databases. Yeah. So, I mean, when we started, we took a kind of I would say, a breadth first approach, right? We kind of added support for a bunch of different databases. And then kind of because that gave us a way to see what common YAML format we could have for this across databases. And once we are able to get that, we kind of, stabilize that. And once that was stable, we kind of went into more like a depth first approach. So kind of adding support for all this data stuff and backups and all of that. And once that is all done, kind of, so I mean, we're still sort of in the process of doing for some of those databases, but once sort of we are stable in there, we're looking to add support for additional databases. And yeah, we're looking to hear from, even from your audience, like, whatever database they would like to see support for.
Yeah.
And we collect kind of feedback from users to.
Well, because that's the thing I was going to say is because some of the databases I didn't see there, and obviously it's totally fine. And there are many databases. So that's why my question is, obviously in an ideal world, it would apply to all of them. But for example, Cassandra, Cockroach, Yugabyte, perhaps there might be special characteristics of those databases that make it harder to integrate with KubeDB, or anything in particular you'd comment on that?
No, I don't think anything specifically makes it harder. I mean, we kind of just went with sort of what are the primary data stores. So primary data stores like a Postgres, MySQL. So once sort of those are done, so once those are done, we're kind of looking to things like Kafka or other stuff, or like a SQL Server, then Cassandra. Those things could be interesting addition.
Yeah.
So I mean, frankly, at this time, those database vendors, I mean, it was still also a case of like, okay, in some cases, database vendors themselves are doing Kubernetes seriously. So if they are doing seriously, maybe we're able to use that. But this is something we have to see what comes next. Yeah.
Yeah. No, I know what you mean, and obviously, we've had a fair amount of Postgres talks here. And because Postgres is just so battle tested, over the years, and is used very, very widely, that seems to be an obvious choice. MongoDB as well too, and we've had talks with Percona where they've talked about MongoDB, also experiences working with operators there. So it's healthy to see that. But like you said, and this is one of the tricky things as well too, because in previous conversations and with some other folks, the conversation of, could there be one operator to rule them all? But because each database is so unique in its own way, to have that seems challenging. However, KubeDB seems to be answering part of that in a way, right?
Yeah. Yeah, I mean, so when we are presenting this one operator to rule them all, I mean, we kind of, to the end user, we are kind of giving this one common interface, but behind the scene, when implementing it, we are still kind of, the database specific aspect of those things are kind of done separately, right? It's just hidden from the end user. like the complexity is hidden from the end user, but the users so the YAML format you just saw, like, kind of you can kind of take most of it and go to Postgres and able to sort of basically, you have to obviously change the kind to say it's PostgreSQL, change the version, but like if you want a TLS issuer, like it looks the same, right? If you want a backup or a Prometheus setup, it kind of looks the same, and that's how we kind of make it easy for you to kind of go from one database to another. So things that are same across databases, kind of we're trying to make sure that they look sort of same to the end user.
Mm-hmm.
Obviously, the things that are specific to a database, we make that specific to that user. Yeah.
And with doing these integrations, being able to support all those databases that you showed, I mean, there's over 10. What have been the things that you've learned along the way, or perhaps maybe had a certain idea going into it, and then once having that direct contact, and I imagine as well too, the feedback that you get from users, has there been anything that surprised you?
I would say that we had quite a bit of challenge in terms of I would say making all the different types of failover scenarios that can happen, because especially in Kubernetes, a pod can restart at any time, and more of them can restart, and how you make sure those things get handled. I would say that has been one of the areas where we had to put in a lot of work and effort, sort of making sure everything works. And especially Kubernetes presents some unique failover scenarios in terms of like, okay, you may have a clustered Mongo, right? Like with 3 replicas, but then your whole cluster can go down. I mean, depending on whatever you are doing, right? Maybe you go to the cloud provider's console and just delete the whole cluster or something like that, or maybe starting the whole thing because you are doing an upgrade. Actually, deleting the cluster is not a common scenario, but like you are doing an upgrade of the Kubernetes version. And how do you make sure that your cluster still stays up, and right, like all those things like that, pod disruption budgets and other stuff, those things we had to kind of implement. So I'd say it's not necessarily a surprise, but like the number of failure scenarios that is possible with Kubernetes is quite great.
Very long. Yeah, it's a long
because of the automation, right? Yeah, like
Yeah.
because of the automation, things can restart, and when it restarts, making sure everything comes back up properly, correctly. I would say that has been an interesting journey for us.
Another question as well too, because you mentioned about in some cases we're working with governments, but I just said it just because very recently the National Security Administration, the NSA, came out with a report telling folks about how to harden Kubernetes. And obviously, one part of it can be, cybersecurity and things of that nature. But what I want to say more about that, because they talk about sort of some good cybersecurity practices are related to permissions and who has access to what and things like that. But in terms of the data side of Kubernetes, and once again, why to run data on Kubernetes, do you feel that also in your experience, you just mentioned the possibility of failures and those issues, but that Kubernetes will slowly but surely become a little bit more boring in the sense that it won't be such a wide landscape that people encounter, but some things that would be more focused? And could data become one of those things that would be more focused?
I mean, the container world is kind of really hard to predict what's going to happen. But I think, I mean, in terms of boarding, I would say as more people get familiar or develop skills in using Kubernetes, obviously it is going to get boring, because these days people are not really surprised to use like a VM, right? Like they expect to go to any cloud provider and just deploy a VM and just be able to SSH into it and use it, all of that. And I think same thing will happen with Kubernetes in terms of data. Yeah, I mean, in terms of as things get more stable and mature, I think it will also become boring. But I think the other thing that I, at least in my experience, is that, I mean, I've been working on it for a while, right? I mean, 4 or 5 years, but it's also like a constantly changing environment.
Yeah.
Like in that respect, it never gets boring, because it's like we're constantly having to find out, okay, like there's this new thing, and then like how you use that, or like how you adapt to that, and it comes from all sides, right? Sometimes it comes from the Kubernetes side, sometimes it is coming from the database itself. So I would say that it hasn't been a boring.
Oh, no. I mean, when I say boring, I mean boring in a good way. Meaning, more controllable, more predictable, and things of that nature. But like you said, it's a very dynamic environment. And also the Kubernetes community, I think, is one of the things that drives that. You have thousands of people from all over the world that are working on this simultaneously. And, there are 3 releases per year. So just to stay up to date with that. And that's my next question. As a former Googler and as someone who's very, very deep in the space, what resources are your go-to? Like, how do you stay up to date? What would you recommend for folks that are out there that, that want to, not fall behind?
Yeah, so to stay up to date, I mean, I personally try to read, and every time a new major version of Kubernetes comes out, I try to really read the change logs. They usually have a very good and detailed change log, like in terms of what has changed. Try to kind of understand those. I would say that will be the one thing. These days, they are also usually do a blog post series after a major release, like just after the 1.22 release.
Yep.
They've been some blog posts on the Cube blog. I would read. And then on an ongoing basis, there is a Kubernetes GitHub repo. GitHub.com Kubernetes/enhancements. So that one, so that one I usually follow, because that's where all the KIPs are, the Kubernetes enhancement proposals. So you kind of can see what's coming up. So I would say that those are the things sort of my go-to to sort of keep an up to date, and I'll keep myself up to date on like what's going on. And I try to follow some of those Kubernetes developers Google groups. I mean, sometimes there will be things there. But then, frankly, it's a little hard to, keep up, because so many things are happening.
No. And like you said, that's just part of the process. Like, you're never going to have too much information. That's not going to happen.
Right. And then sometimes things are like discussed, but then one of the things that we have a policy with KubeDB today is that we try to support at least last 6 releases of Kubernetes, which is like at least 18 months.
Yeah.
And as a result, even if something new shining comes out, we are not really able to use it. Like for example, the server-side apply thing has been ongoing for a while. If you know the Kubernetes server-side apply, but it just went GA with 1.22. But frankly, we're not going to use it for some time to because we see people staying on quite a bit old version of Kubernetes. Yeah, so we have to make sure that everything works. I think, sorry about the
All good.
He just told me that his PC hanged up, or maybe he had a power outage.
That's okay. That's not a problem. It's so funny is, we're talking about these extremely advanced technologies, but the number one most difficult technology that I use is Zoom. The amount of problems that we have because of Zoom, it's unbelievable. So no, that's totally fine. What I would say is that this gives us the excuse perhaps to meet at another time with Fahim. And if he wants to do the demo at another date, fine by me.
Yeah, we would love to do that. I mean, actually, so let me know.
We can work that out. In the meantime, thank you very much. This is amazing. I mean, like those slides, like showing the reasons why, the mindset behind this, the advantages, the benefits. It's really healthy for us to get these comments out there in the open, because sometimes we feel like we're just crazy. But you've been working on this for a while, so it's very nice to hear all that. Obviously, we linked KubeDB in the chat on YouTube, and we will definitely be continuing the conversation on Slack. So anyway, thank you very much for your time today, and look forward to reconnecting so we can get the full-fledged demo, and it'll be very interesting to see the other questions that folks out there will have.
We'll love that. Thank you, Bart.
All right, thanks a lot. Have a good one. Thanks, everybody. Bye-bye.